Hi guys. Sorry I can't be there today. I'm at an important meeting, but we'll catch up tomorrow with another exciting lab about circuits. But yesterday you did one where you learned how to use those multimeters to measure a few different things. You learned how to measure resistance, which was measured in ohms, and there it's abbreviated with a little omega symbol. You learned how to measure current, and that's abbreviated. It's measured in amps, which is short for amperes, and its abbreviation is just A. And you learn how to measure voltage. And voltage is measured in volts, abbreviated V. What are these things? Well, resistance, I mean, it kind of says it right in the name. It's just basically how hard is it, how hard do you have to push to get current to flow through something is what resistance means. It really measures the difficulty in getting current to flow. Things like metals have very low resistance. It's very easy for them to let electricity flow through them. Things like air have very high resistance. It's hard to get electricity, current to flow through air. Okay, so what is this current stuff? Well, current is really just a measure of how much charge flows past a point at any given time. So if you have a high current, that means a lot of current is a lot of charge is flowing. If you have a low current, it means not much charge is flowing or it's moving slowly. The last thing we measured is voltage, and this is the hardest to understand, and it's going to be at the heart of what we talk about coming up. And really, that's just how hard um, a battery or something is pushing on the electrons. So for right now, we'll just say battery, but later we'll expand that definition. How hard the battery is pushing on charge. Now this seems weird. We'll definitely get into it later. But what's important to realize is that all of these electrons that are in there all repel one another, so they're all pushing against each other all the time. So at any given point, wherever you have any material that's made of atoms that has electrons, there is some push happening there. If you get a situation where the push is greater on one side than it is on the other, then you get something moving. And it's kind of like this situation. If you have a box, got a guy here, another guy here, and he's pushing. And this guy's pushing that way and he's pushing that way. If they're both pushing with like 5 newtons, nothing's happening to that box. It's going to stay still. But if this guy can step up his game, go to 15 newtons, then the whole guy is going to accelerate that way. So the same thing happens when you talk about voltage in a circuit. If you have a harder push on one side than the other, you can determine if current is going to flow or not. And that's what this is all about. If you can make current flow through a light bulb or a toaster or an iPhone, then you get the device to work. But you got to have a harder push on one side than the other in order for current to flow through these devices. So we're going to learn how to do this color coding stuff to help us understand circuits. I'm going to walk you through this sheet that you got at the end of class yesterday. We'll do some of these together, and then you've got another sheet that you're going to do after you turn the video off. So here's the color codes. Red is where the push is the highest. Blue is the lowest. These are the two most important colors. We'll start with those. And then somewhere in between, you go from red to orange to yellow to green to blue. All right, so what does this all mean? Let's do an example. All right, this is a circuit that has a battery right there. That's good. So this is the positive side. We know that because it's got the longer part there. This is the negative side. So what we do is we start with red because this is the highest push. The positive part is where that charge is really pushing against each other. So let's change this to red highlighter. Where'd that go? So we start here and we follow this wire until we hit a resistor or something. Oop, gotta stop. All right, can I go here? Oh, I could also go there. And then, whoop, hit a resistor, so I have to stop. Oh, why'd that go away? All right, now we go to the negative side, and we know that that is the lowest because that's effectively 0. So we're going to change that to blue. And where are you, blue? There you go, do the nice blue. I'm take that until I hit a resistor. Oh, hit one there. Oh, hit one there. So now what we know is because these guys have red on one side and blue on the other, that's a very big difference going from the highest to the lowest. That's a big difference in push. That's a strong person pushing against a weak person. So what you get out of that deal is you get yourself some glowing light bulb action. Careful with how you draw these. Let me go back a little bit there. Oops, that's better. So we'll have some, sorry about that. We'll have some glowing light happening there. That's good news. All right, let's do this guy over here. It's a little more complicated. Okay, so where are we going back? Let's do red because I got it there. All right, it's the positive side, so you keep going until you hit a resist. Oh, there's one. All right, well, I can go this way and then, oh, don't burn. Okay, so now let's do the blue on the bottom side there. All right, starting here, gonna keep going until we, aha, what? Don't. Yeah, I'll try this. Okay, no, wait, this way. No, oh, no. And then this is the same. Okay, so we're all done. Here's the deal. Which of these 3 bulbs are going to light? Well, if you guessed this guy, you're right, because it's got a different push. Red on top, blue on bottom, there's a difference. Same thing here, red on top, blue on bottom, there's a difference. But what about this guy? Well, you see that it's blue on top and blue on bottom. That's the same strength of push on each side, so this one will not light up. The current will just choose to go instead through those 2 bulbs. All right, you getting the hang of it? All right, you can tune me out if you think you got it, or you can listen up and I'll do a little bit more. Let's do, again, red over here. I already got blue. Let's do blue. Here's the negative side. It's not blue. Let's go to highlighter. We'll make it nice and obvious. Blue. Okay. There. Come on now. Oh, stopped. All right, gonna go this way. All right, good. Got it. Oh, stop. Wait, that way. No, stop. All right, notice how I had to stop there because I can't go any further. Let's check it with red. All right, take it off. Cruising. I think I can get through. Nope. I can go this way. Maybe I can get over. All right, so which of these bulbs is going to light up? Well, this one, yes. I'm going to change that color. Sorry, guys. Very good with this. Okay, so this will light up. This one's got blue and red. Yep, that'll go. This one's got blue and red. Yep, that will also go. Pretty cool. Check out that the current goes in different directions. Here it goes from left to right. Here it goes from right to left. Here's from left to right again. All right, let's do this last guy. And let's go back. Highlighter. Let's go to it's red. Okay, good. Start the positive. Doop. All right. Doop. That's it. I'm done. All right, let's go to the blue. If you're still with me, I appreciate it. Darn. All right, how about this way? All right, how many bulbs will light? What's the answer? Say it loud and proud. That's right, 17. No, just kidding, just 2, these 2. Why won't this bulb light? Because it's blue on top and blue on bottom, which means they're both directly connected to this part. There's 0 difference between the 2 edges, so light will not flow. All right, still with me? Should we do a couple more? Let's get rid of this thing. I didn't want to do that. Okay, let's do eraser, get rid of this because I don't know what that's doing there. All right, and let's go back to highlighter. Let's go to, okay, we're blue, so here we go, blue. Oh, this way. Oh, shoot, that's it. All right, let's do this one, blue. Oh, shoot, that's it. Okay, now here, that's it again. All right, let's do the red. Red. All right, kick off. Uh-oh. Uh-oh. Same deal. Okay, so let me think. We've got to get from red to blue. And what was the color that was in the middle? Look at it. You guessed it, Chester. It's yellow. So we'll go. So will there be light there? Yes. We'll come back to talk about that. How about this? We've got to get from red to blue, but there's 1, 2, 3 steps to get there. So if you guess that it's going to go orange, yellow, green, then you are a smarty pants. Let's get that. This is not really orange, but I don't feel like messing with it, so there we go. And let's get that green in there. Why do you suppose there's no good orange in the stock colors? All right, how many of those bulbs are going to light? Difference, 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 difference. They're all going to light. Let's talk about this guy. It's a little confusing. So now you got to get from red to blue, but there's only 2 ways to do it. Do you go orange, yellow? Do you go yellow, green? Or do you do orange, green? What do you think? Orange, green, that's right. Split it up evenly. It's not a huge deal, but we'll talk about why it matters later. Probably just passed an orange, sorry. Okay, now let's talk about the brightness. All right, so this guy is jumping from red to yellow. How many jumps is that in the color scheme? That is a jump of 2 because you skipped over orange. So that's going to be pretty bright. This guy goes from yellow to blue. That's also a jump of 2 because you skipped green. So that's pretty bright. How about this one? Going from red to orange. That's a jump of 1. So it won't be quite as bright. Also a jump of 1, not quite as bright. Same, these are all jumps of 1, not quite as bright. How about over here? We go from red to orange. That's a jump of 1. And these are all going to be about the same. This is misleading. I know what you're thinking. You're thinking, wait a minute. Going from red to orange is 1, and from green to blue is 1. But it isn't going from orange to green 2 jumps. And yes, it is, and that's where our color scheme kind of breaks down. It's not perfect, but really if you had a numerical way to think about it, if you said this is like 9 volts here and this is 0 down there, volts describes the push, is a nice strong push of 9 volts there, be 9, 9, 9, 9, all the places that it's red, 0, 0, 0, 0, all the places that it's blue, and then it'd have to drop evenly across. So this would go to 6s, 6 volts, this would be 3, and you'd see that it's the same jump. Here it's from 9 to 6, that's a drop of 3 volts. Here it's from 6 to 3, that's also 3 volts. From 3 to 0 is 3 volts. You go 3 volts here, 3 volts there, 3 volts there. What do they add up to? 9 volts. It's a 9 volt battery. Okay, that's a lot. We'll get into this tomorrow with more descriptions, more detailed discussion of this whole thing. But for the rest of the period, please work on the sheet that your substitute teacher will give you. All right, thanks guys. Have a great day.